Hello class, I'm going to use this video to answer problems number 7, 8, and 9. These problems are very similar to questions number 3 and 4, number 4 in particular. So I've already answered questions 3 and 4, so I'm going to kind of quickly go through number 7, 8, and 9. Looks like we're given data, and we're asked to calculate the correlation coefficient and a scatter diagram, and then really interpret the meaning of this correlation coefficient when in context to a critical value for the data set. So first, click the icon to view the data set. Let's do that. Here's my data. So it looks like I have 1, 2, 3, 4, 5 data points. So that's going to be important to remember when we look at the critical values table, right? My value for n is going to be 5 when I look at the second table, because I have 1, 2, 3, 4, 5 data points. Okay, so let's open this data up in StatCrunch. And here we go. So the steps are stat, regression, simple linear, x is x and y is y. I press compute, and let's make this a little bit bigger. If I want to take a peek at my scatter plot, I press the arrow key, and here's my scatter plot. Looks like I have 2 points above my line, 2 points below. You note where the line falls, somewhere between 2 and 4, and so on. So you can select your scatter plot from here. Okay, let's go back to our data. Compute the correlation coefficient. Well, if I press the arrow back, my R, here's the correlation coefficient. It looks like it's 0.429. If we have to round 3 decimal places, maybe we'd write 0.430. 0.430. So that looks good. Next, we have to determine whether there's a linear relationship between x and y. Well, to do this, we need to come up with a critical value for our data set. And again, remember, there were 1, 2, 3, 4, 5 points. So when I click on this table, and this is, by the way, all these tables are in the back of your book in the appendix section. I go down to n equals 5, so my critical value would be 0.878. And if you look, 0.878 was accepted. Okay. So my R is less than 0.878. What does that mean? Well, because the correlation coefficient is positive, and the absolute value of the correlation coefficient is 0.430, this value is not greater than the critical value. Therefore, no linear relationship exists. Okay? If this number was greater than the critical value, I'd say yes, a linear relation exists. If our correlation coefficient is less than the critical value, we say no linear relation exists. Okay, so that's question 7. Question 8 is pretty much the same concept or the same idea, right? I'm going to open up my data in StatCrunch. And again, if you felt like you really didn't want to do this in StatCrunch, again, you could go to your textbook. I believe it was page 193. And here's where you can calculate the R, right? That correlation coefficient. If you wanted to do this by hand, here are the definition for all your variables. Okay. All right, so back to the problem. So again, I'm going to open this up in StatCrunch. And I press stat, regression, simple linear. And I have my x and my y variables. I press compute. And my R value is right here, 0.087. So maybe we'll round this to 0.088. And that's what you would enter down here, 0.088, because it does say go 3 decimal places. Okay, and the steps again, question 7, question 8 are very similar. Question 4 also is very similar. And then we take a look at question 9. All right, now they're asking for us to determine the least squares regression line. So we can do this in StatCrunch very quickly. We can also do it by hand. Page 210 in your textbook looks like this. And it says, okay, if we want to calculate or compute the least squares regression line, think back to when you were in high school, right? The equation of a line was y equals mx plus b. In this, instead of using m, they use b sub 1, and that indicates my slope, right? And y equals mx plus b, the m was your slope. So in this case, the b1 is your slope, and it's found by r s sub y over s sub x. So we're actually given these values in the problem, and then the b sub 0 is my y-intercept. And again, we're given these values in the problem. So we could calculate this equation by hand, right? That's what they're looking for, y equals, right, b x plus b, right? And they're the values we need to calculate those things, right? The r, s sub y, y mean, s sub x, x bar, right? Again, these are the things we need to calculate the slope and the y-intercept. But we do have StatCrunch, and for those of you that have to take MAT 240 next semester, you're going to use StatCrunch quite a bit. So why not get in the habit of using StatCrunch, right? I press Stat, Regression, Simple Linear, X, Y, Compute, and again, let's make this a little bit bigger. Sorry about that. You can see my slope is going to be this negative 0.6812. My y-intercept would be the 7.1446. So if I had to enter my answer into this problem, I'm going to put negative 0.681. How many decimal places? 4 decimal places. Let's see if I can copy and paste here. And yeah, right, 1, 2, 3, 4 decimal places. And then for my y-intercept, again, I think we have to round this. So 0.1, let's see, 1, 2, 3, 4 decimal places. So I would just make that a 7. And that would be the equation of my linear regression equation. Okay? So I hope this helps you get started. Please let me know if you have additional questions. Thanks for watching.